In our fourth algorithm here, we're going to work through the shortest connection. Here's a quick little visual to give you an idea of what we're talking about. So imagine that we have a tap and we have 4 garden sprinklers represented there by the nodes, the round sections, and they need to obviously have water going to them. So they need pipes to connect them to the water source. One way to do that is to connect each sprinkler with a pipe to the tap, or perhaps a more efficient way to use less piping would be to connect one first to the tap, one node, one sprinkler, and then attach each of the sprinklers to each other. And when we try and solve problems like this, we're solving problems called the shortest connection problem. So let's put that into practice now. Bit of a summary here of the steps that we'll need to go through. You need to start with a complete network diagram, so it can't be disconnected at all. Then you would remove the largest edge that you can find, so the longest length, it'll have a number on there. But providing that you don't isolate any nodes along the way, you can't have a sprinkler left out on its own with no pipe connecting it. You keep repeating those steps until you can't remove any more edges, and the resulting network is called the MST, the minimum spanning tree, and that we add the values for the minimum length. Let's do that. So here's our example. Having a look at the sizes of the numbers here. Again, maybe keeping in your mind that each node, each little circle here is a sprinkler, and that we're connecting them with pipes. Strange shaped pipe there, but anyway. So what's our largest number? The longest edge here. If we were to remove that, does it isolate any sprinkler? No. So then that's the one we remove. And we keep repeating that process. What's the next longest edge? So edge, look at the numbers. 500 is the longest one. If we remove that, is anything isolated? No, we're fine. So let's remove that one now. 500's gone. And here's our diagram still. Keep going. What's the next highest number? It is 310. Can we remove this one? Yes, we can. And therefore the sprinklers will still be connected. What's the next largest number? 300. If we remove this one, this node over here, this sprinkler, will not be connected anymore. So we can't remove anything else because it would be isolated. So therefore we have found the minimum spanning tree. And what is its length? Well, to do that, you add up the 3 numbers here, 300 plus 240 plus 230 to have a length of 770. We don't have any units given here at this point in time, but that's the length given there. Let's do another one. This time using this idea of this nearest neighbor algorithm to find the minimum spanning tree. Let's have a quick look at it, looking at our nodes, looking at our edges. Again, you could imagine sprinklers if you like, and these are pipes. Look at the largest number on that diagram. What is it? 15. Should probably worth mentioning here, if you have numbers, if you had 2 15s, for example, which one do you remove? It doesn't matter. You get to pick which one, which means that the diagram that one person has could be slightly different to the other person, but they'll still have the same length, wouldn't they? Because we're removing the same number. So, removing the longest edge possible without isolating. We will remove this 15. Is any node isolated? No, we could still get to each node or each sprinkler. So that one goes. What's the next biggest number? 14 over here. Can we remove that? Yes. This one won't be isolated, so we can remove that safely. Next biggest number, 13 and 13. But will removing one of these isolate something? Yeah, it will. So as it says here, this is the next longest edge, or arc, sometimes it's called, but removing it would isolate this node, so we're going to leave it. Instead, we'll look for the next largest, which is over here, this 13 here, and we can remove it because these nodes you can still get to through other paths. So even though this 13 is now the next biggest number, we can't remove it because it would isolate the node. So now we move to the next biggest number, which is 12. We have 2 12s. Will removing either of them isolate a node? Yes, this one will. So we can't remove that 12. So go to the other 12. Could we remove this edge? Yes, we can. And so that's the one we would remove because that's the next longest one. So here's our diagram so far, our network. Can we remove anything else? After 12, the next biggest one is 11. Can't remove that. Can't remove the 10s. And so we stop. And so we have found our MST, our minimum spanning tree diagram. What's its length? You add up the numbers. Doesn't matter which order you add them up. We've got 10 plus the 7 plus the 8 plus this 10 plus the 13, the 12, and the 11 to get 71 units. So there's how we do minimum spanning trees. There's some questions to do. Thanks for joining me.